So what I want to talk about first is I want to take a look at the JetNet course and specifically kind of the organization and structure. You're not going to spend a ton of time on the JetNet course site, but I will ask that you, here, let me switch over to the screen too here. I will ask that you go there to be able to do some specific things. So when you log into JetNet and you click on our course, the organization is pretty simple. I think I don't have the editing turned on, so yeah. So this should be very similar to what you see. And you'll notice I'm a very plain person. I don't put posts all kinds of crazy stuff on there. So I tried to create sections that are based on sort of utility. The first one is syllabus and agendas, because you're probably going to be going there most often to grab copies of the agenda. So if you click on that, it'll open up a new window, which shows you the kind of a calendar of the semester. And so each one of those days is going to have a link to an agenda. So you can always get access to that, as well as the syllabus. So that's always available to you. By the way, you guys could still see when it opened up a new window. You could see the new window, couldn't you? Okay, cool. The next thing, course notes. Because most of the notes that you're going to be doing are based on videos, the course notes page isn't really going to contain a whole lot of what I would say is literally the notes for the course pack, but the course notes page will contain Maple notes. So like each one of the sections, whatever I do in Maple to sort of illustrate what we're doing in the section, I will post those notes there. And it turns out for 1.1, there's actually nothing in the course pack that requires Maple, but I'm going to post something there just as a placeholder. It'll probably be what we went over in class last week. Some other things that are there, a blank copy of the course packet notes so that you can get to it, as well as the playlist for the videos. So course notes page, pretty self-explanatory. The graded assignments, pretty self-explanatory. It's going to be a laundry list of all the assignments. And I've also listed the due dates, just so you can see what's going on. So you'll notice that welcome survey, I expected everybody to have that done before the first day of class. Looking at you, Quentin. And Maple Basics assignment. I'm kidding, Quentin. You obviously you weren't here for that, so you don't know. The Maple Basics assignment and then problem sets. And you'll see there's an investigation coming up. There's more problem sets. And Paul, to your question of, how long is it going to be before we're hitting that first exam? You'll see that I've really front loaded a lot of problem sets for chapter 1, because it turns out chapter 1 is pretty important. It goes over a lot of kind of big ideas that are going to be with us for the entire course. And it's also a chance for me to give as much feedback as I can to you for the first chunk. So I'm expecting these problem sets are going to come pretty quick, pretty fast, and I don't know if they'll be furious, but we'll see. Suggested practice, as the name implies, it's a list of stuff by section. You'll also see that's where the classwork exercises, they're also posted there. But by section, these are pages in the book. Remember, you have access to the book, and you can use that PDF as a reference only until your copy comes in the mail, which who knows, it could be another 10 to 13 weeks from now before it does. So. Okay, so suggested practice problems are there, and they really are me looking at kind of the way I assess and what I assess, and I'm not suggesting problems that kind of take you off the beaten path to stuff that we don't cover on purpose. I'm posting things that you will probably want to practice, and if you're not feeling like you get enough practice with the homework and the coursework or the classwork, then you can try some of the practice exercises too. The class resources page, has anybody taken a look at the stuff that's on the class resources page? Maybe? No? Okay. Well, I'll pull it up just to show you. There's the full textbook for reference only, but you can use it. My advice would be just click on it, download the PDF, have it locally for yourself. That way you don't have to worry about getting access online. There's other links, there's Maple stuff, there's a whole bunch of stuff on Maple. There's stuff for Desmos, if you're familiar with the Desmos graphing calculator. I assume most of you are. There's some useful differential equation stuff. There's some really cool calculus tools. I don't know if you guys are familiar with the websites Derivative Calculator and Integral Calculator. Have you seen these? Let me click on it. I'll show you one. Derivative calculator. This is what the web page looks like. Derivative-calculator.net. You type in the thing you want to take the derivative of, and not only does it show you, but it will give you steps, and it's like a tutorial for doing this.
Use this all the time.
So, yay! So good. I'm glad to hear that. Then the nice thing about it is now that you've cleared the hurdles of Calc 1 and 2, and many of you have cleared Calc 3, you're past that. You must be taller than this to enter. And pretty much from here on out, nobody's going to be like, and you should do this by hand without using any calculator or anything. Pretty much gone are those days. Every once in a while, somebody might be like, wait a minute, you don't know how to take the derivative of that? What's wrong with you? In the same way that, we look askance at somebody who pulls out a calculator to do addition, of, single digit numbers. You might have to suffer those slings and arrows. But for the meantime, you've got access to these tools on there. There's also a link to what I thought was a really terrific video series. And if you've never seen it, and you're looking for something to do over the weekend and you're tired of listening to my voice on videos, you can always go check these out. These are put together very, very well done, professional, way better than anything I could do, by Welch Labs. And it's basically like a primer on imaginary numbers are actually real things. And for those of you going on into any kind of engineering, which is practically all of you really want to get comfortable with the idea of imaginary numbers being just another thing that exists in the world, right? Because they get used everywhere. We're going to use them in this class, but you need to get comfortable with those. And it's actually a really nice sort of historical look at the development of imaginary numbers, why they're useful, where they came from. And it's the kind of thing where you can watch a couple of videos and set it aside and come back to it later. There are a couple that are really useful. The complex plane and complex multiplication. Those two become really, really helpful. So worth checking out. And then last but not least, there are two sections down here that are about submissions. And so the first one is assignment submissions, and the second one is midterm exams. And so I'll be posting the midterm exams, like the chapter 1 exam. I will post it right there for everyone to see. And I'll also have a space there for you to probably turn it in. I haven't decided yet whether I'm going to do the turning it in through JetNet or emailing it to me. But anyways, so the midterm exam thing, that's to come in the future. But you'll notice there's a spot there for you to click on problem set 1 and problem set 2 to submit. And if you do that, if you click on it, you'll notice that this is, well, I don't know exactly what it's going to look like when you click on it. When I click on it, I see how many people have submitted and all that stuff. But it's basically going to give you an opportunity to submit, and you can submit for the problem sets. You can submit a PDF document. You can submit a Maple document. Those are the only two types of things that you can submit. And as it kind of lays out on the instructions for the problem set, see if I can pull that up. I think this is the one. Is this the one? Yeah, problem set number 1. You'll notice at the top, it says, complete each of the following problems in a single Maple or PDF file. And I'm not kidding when I say that. So if you want to do stuff by hand and then scan it in later and make a PDF out of it, that's fine. But don't send me a PDF and a Maple file. You're going to have to find a way. You'll have to print out your Maple and then scan that as part of the document, or print out the Maple as a PDF and then merge those documents together somehow. But that's on you. I have a bugaboo about people, especially in this class, turning in, and those of you who have looked at the problem sets, you know that there's like 1, 2, 3, 4, 5 problems, right? And so some of them have multiple parts. And so what happens sometimes is people will use Maple for part A and then do part B by hand. And it's a real bugaboo of mine that people will do the Maple thing and then do the thing by hand, but they'll be in two completely different areas of the document that they submit. And so I have to kind of flip through the page to go back and forth to your Maple. Because when I grade this, I tend to grade these assignments by looking at, okay, everybody's problem 1, part A. I look at everybody's part 1, problem A. And it's to guarantee that I'm doing as kind of uniform a job and giving constant feedback to people. And so if I have to go, yours is right in line with everything else, and then all of a sudden somebody else's, it's on the Maple document that's at the end of the file. It sucks. So don't do that. As a general rule, and you can quote me on this if you want, don't piss off the person who's grading your papers, right? It's usually just, a good rule of thumb to stick by, right? Don't piss off the person who's grading your papers. And I'm telling you, it will greatly anger me if I have to go skipping through multiple pages to be able to say, part A is here, but part B is 5 pages later. I don't want to do that. So don't make me do that. That was easy. Okay, so right now you can turn in problem set 1. You can turn in problem set 2. I fully expect none of you have started problem set 1 and 2. If you started problem set 1, good on you. When is problem set 1 due? Dum, dum, dum.
Next
1 week.
Wednesday.
I'm so glad you're paying attention. If you click on the agenda, you'll notice down on the homework area, you'll see I'm not trying to hide anything. It says it pretty plain. Problem set 1 is due by 6 p.m. on next Wednesday. So a week from right now, a little less than a week from right now, I expect you to submit that via JetNet, right? And the reason it's by 6 p.m. is I don't want people showing up to the class without having it done. And I don't want people being like, if I just skip class, I can finish it. No, I want you to finish it before class. So submit whatever you have done, submit it before class so we can start working on that. We can take a look at them. We can answer questions. We can go over stuff. Typically, I won't spend tons of time on the problem sets because you will have spent plenty of time on the problem sets, right? So that covers submission of work and all that stuff that's available online. The only other thing that I wanted to do real quick was to do a kind of a quick brief rundown on sort of the big ideas for section 1.1. So let me stop sharing my screen here if I can stop share. And I'm curious how many of y'all have had a chance to watch any of the videos, even just like the first one for the lecture videos. Had a chance to watch them. Started them, a couple people. Okay. So the lecture videos, there's, I think, a total of 5, but they're of varying lengths. It just depends on how soon the particular section sort of ends, if there's a logical point to end. Typically, I don't make videos that are less than 5 minutes, and I try really hard not to make videos that are more than 20 minutes. The only exception are the class videos, the videos that we're doing here in class. So if you haven't had a chance to take a look at the notes for section 1.1, what I wanted to do real quick is just kind of touch on a couple of what I thought were sort of key topics. And I'm going to pull up my document camera. I'm just going to kind of make a little list of key topics that I think are important. So let me see if I can change over to share screen. Boop, boop, boop. So I'm going to do section 1.1 key points. And again, I'm not going to go through, detail what they are, but I'm going to kind of highlight some of the important ones. Even before section 1.1 starts, there's actually a chunk of just a single page of some background information, and there's some background topics that are worth paying attention to. We already talked about some of them last time. Some of the big ideas are, what is a derivative? And derivative as rate of change, and as well a function itself, right? Because the derivative of f, f prime, is itself a function, and we can treat it like a function. The other two things that were kind of important in that sort of preamble section were, what is the idea of proportionality, I guess you could say. And so the idea that A is proportional to B implies, it means the same thing as saying A equals some constant times B. So that's another big idea, and that's going to pop up in our modeling, our differential equations modeling. And then the last little bit was the idea of using test intervals. to determine signs of the function of I'll call it function. So for example, if I'm curious where f of x is positive and where it's negative, I start off actually by finding out where it's 0 and where it's undefined, and then I look around those particular values. Because if I know it's 0 here, then it's either positive over here or it's negative over here. It has to be, right? So those were some big ideas in section 1 point, or the actual notes before 1.1. But 1.1 itself, we kind of dive in, and I'll say another huge idea that's going to be important for us throughout the whole thing is the idea of unit analysis. So can you look at an equation and verify that its units work out? In other words, if I give you an equation like force equals mass times acceleration, then I don't actually have to tell you what the units for force are, because the units for force have to be equal to the units of mass times the units of acceleration, or else the equation isn't valid. An equation is only valid if its units on one side match the units on the other side. Or another slightly more robust way of saying that is the units of every term in an equation have to be the same, right? Or else you wind up adding two things that are not like terms, right? So you say one marker plus one mouse, and you can't add those two things together because they're not the same units, right? Just as a side note, what do you get when you add 2 Baptists, 3 Methodists, and 1 Roman Catholic?
Marked down on your math exam?
Oh, yeah, you probably would. I would say the best answer so far that I've heard is you can't, because they don't have a common denomination. So I'll just hit mute on everybody so I don't have to hear you complain. Thank you. Anyways, so unit analysis becomes super important. And that's one of those things that's like important everywhere in your mathematical and science careers. You probably use unit analysis all over the place in physics. You should. And chemistry, even biologists. Even biologists use unit analysis. That's how important it is. We even let biologists use it. It's crazy. So the next thing that we ran into was this idea of an equilibrium solution, or an equilibrium. Yeah, just solution. And so those of you who had a chance to watch the videos, did you get to that part? Did you run into the definition of what an equilibrium solution is?
I had one more to go.
Okay, no worries. Equilibrium solution just basically boils down to where's the derivative equal to 0, right? Because equilibrium means a state of no change. That means the rate of change is goose egg. So that's a big idea. Another big idea for us is this idea of long-term behavior. I'm going to even put it in quotes here. Long-term behavior. And really, that's just English for limit, right? The limit as t approaches infinity, right? The limit as time goes by. Somebody's at my door. No idea why. My dogs are going to bark though, so apologies. Did the doorbell ring? The doorbell rang, but there's nobody there. That's weird. Anyways. So when we say what's the long-term behavior of a function, we're really saying how does it behave as the dependent variable blows up to infinity over time, right? And most of the time in this class, our dependent variable is going to be, or excuse me, our independent variable is going to be time, right? That's just the way things work out very commonly. We also talked about the logistic versus the exponential growth models. And so you're going to definitely want to watch the videos about those to make sure that you understand where does this logistic model come from and how is it really just a modification of the exponential growth model. Another big idea that comes across here and that becomes super important in this class is qualitative versus quantitative analysis. Quantitative. So you can actually look at a differential equation and you can try to solve it to do some kind of quantitative analysis. What does the solution look like, and can I make predictions of the solution? That's quantitative analysis. But you can take a look at the differential equation without solving it and start asking questions about, so what does this equation mean? What do each one of these terms mean? And that's more of a qualitative analysis instead of a quantitative analysis. And then I think that's probably it. That's probably the main big ideas. There's some other stuff in there, obviously, but that gives you a rough sort of breakdown of some key ideas that you should be paying attention to when you're watching the notes for 1.1. What I want to do right now, well, first of all, does that make sense? Is there anything in there that you're like, wait a minute, what? I didn't get that. I watched the videos. I didn't see that. I will take your stunned silence as indication that there's no problem. What are you eating, John? That looks really good. Is that a Dorito? No. Oh, all I got is coffee. Ugh.
Oh, they're pretzel crisps.
Are those gluten-free pretzel crisps?
And then yeah, and then I dip in cream cheese.
Man, you are just living in the lap of luxury.
Yeah.
Living large. That's the John Ryder story right
that's
there.
the move.
That is. Okay, well, I'm going to break us up into our breakout rooms here. And what I want us to do is focus on the classwork. Oh, whoops, I didn't mean to do that. Oh, maybe I did. We're going to focus on the classwork. So right now, take a second and make sure that you've got access to the classwork document. And it should be a new PDF. It's going to have 2 pages now. So if you click on the link, it should pop up with 2 pages. And if it only pops up with 1, you can just hit refresh and it should come up as a new document. So what I want you to do right now, take a minute while I'm breaking people up into groups. I want you to read through the questions. We already looked at the questions for the intro, the getting started stuff. But I want you to take a look at the 1.1, section 1.1 questions. Just look them over. There's 6 of them, interestingly. And in your team, you're going to be assigned to come up with a solution for 2 of those problems. And then we're going to come back together in a little bit and give you a chance to present your solutions. So in your teams, and just so you know, Quentin, I've got you on a team with Anthony, Paul, and Wyatt. They were 3 people before, now they're 4 people strong. But we are missing 2 others today. So the group that was 3 last time, well, the other 2 were 4, is going to be a group of 4 this time, while the other 2 are going to be 3. Who would have thunk it? Anyway, so give me a second. Let me pull up the breakout rooms and I'll get you assigned here. But in the meantime, take a look at that document. Oops, that's not what I wanted. No. Oh no. Oh, there we go. Manually, yes, that's what I want. Okay, so first one. Oh, Anthony, you're messing with me having Tony be your name on here. Oh, would you prefer to go by Tony?
I actually changed it for that one meeting that we did, and I don't know how to change it back. I forgot.
Oh, okay. So if you go where your picture is on Zoom, if you hover your cursor over it and the 3 dots, you can go in there, you can change it. That's cool.
Should I change it to Anthony?
Chris.
Chris? Okay, I'll do that.
Okay. So I'm going to open up the rooms. Remember, you're going to have a chance to work with each other, and I do want you to not only have your cameras on, but audio on. And if you want to be able to share your screens with each other, that's cool. Just take turns if somebody wants to show something. Go for that. So I'm going to open up the rooms now.